Okay, I guess we'll wait a minute or two, see if anyone else shows up. How's everyone?
Good.
Good. I was a little worried about the weather yesterday. They were saying we might get some snow. We only saw flurries, although I understand people north of here got a little more. Winter wasn't going to let us go without one last kiss.
It snowed a little bit before Washington.
What's that?
It snowed for like 5 minutes and stopped. So.
Yeah. That was actually a relief. Okay, I guess we might as well get started. The first few slides are just kind of introductory, so people can catch up as they come in. I wanted to take a minute as we get started to kind of show you something that's been going on in my life during these classes. Last year, shortly before we started these classes, my wife gave birth, unfortunately prematurely, to two twin boys, Joseph and Benjamin. They were on life support for a while, and then finally came home still on supplemental oxygen. But by Christmas, they were pretty much off of all the support, and they're learning to play together, and now Benjamin is actually helping me with these classes. And the reason for putting this here is I wanted to make an analogy between this and bringing Linux into the enterprise. Sometimes it's a bit of a struggle and it requires some patience, but if you stick to it in the end, it'll be worth it and you'll see the rewards. So, in the beginning, before we had web servers, we just had the internet. It was just the TCPIP protocol and a few hundred sites located on it. And the only kind of services that you could have on the internet were things like Telnet, where you logged into a server remotely, or FTP, where you could transfer files, or RCP or RSH. But the problem was you had to give credentials in order to log in, and then once you were logged in, you were running a session which took up memory and CPU cycles for the host that you were connected to. At best, a large VAX could support a few hundred users at 9600 baud, and then it was pretty much maxed out. So there were attempts to create a way of interacting with a host that wouldn't use so much memory and CPU. And one early attempt to do that was a protocol called Gopher. There are probably very few people in this room that remember Gopher. It was only around for about a year before HTTP and HTML came along. But there are still Gopher sites. It's kind of like HTTP, except it's text only, but you can have hyperlinks to other locations on the web, and you can set up informational sites with it. And then along came HTTP. Tim Berners-Lee from CERN over in Switzerland led the effort to define the protocol, and people at the University of Illinois Urbana-Champaign came up with the first browser which would interpret and show you pages written in HTML. There are some RFCs that define the basic protocols that make up the web, but they have evolved over time. We're up to HTML version 5, I think, now. These are just protocols, and of course, in order for the protocols to be useful, you have to have software which will run those protocols, which will obey the standards. In the Linux world, the server that runs HTTP is called Apache. Apache.org is an open source project. They do a lot of things. The basic Apache web server runs on Linux, Windows, FreeBSD, Solaris, just about anything that you can imagine. And you could also take the source code and compile it for a new platform if you had something else like an ARM chip that you wanted to run it on. Apache is the world's most popular web server, even on Windows. More Windows servers run Apache than run Microsoft's IIS. As far as web browsers go, the web browser constructs a URL, a universal resource locator, which is that string you're used to seeing, http:// and a host name. It sends that request, formatted in the URL format, and on a Linux box, your xinetd program receives all the requests that are coming in off the network, and it dispatches them to programs that have bonded to ports on the network. Typically, Apache, running as HTTPD, would bond to port 80, or port 443 if you're running encrypted web traffic. And so the URL request gets passed to the HTTPD program. And in the very simplest case, HTTPD will look up internally a file that's full of static HTML content, and then it'll send that back to your web browser, and then your web browser interprets the HTML, hypertext markup language, and it paints the screen for you. Now the nice thing about this is your browser on your PC or your home workstation is doing most of the work, so it's not using up resources on the host. The host just spits out a file and then its part of it is done. So this way you can support thousands of users using less resources than if you logged a bunch of people in using something like Telnet. So here's a kind of a graphical representation of what HTTPD does. On your disk you have a root directory. The very, very early implementations of HTTPD didn't shield your disk from outside access. They had a directory where your web files were, but a clever person could put a couple of / slashes in front of a file name and actually walk up your directory and see your whole disk using the web browser. So they fixed that, and now you have a virtual root directory for HTTPD, and that's where the files that it serves up to the web come from. But out there on the internet you have a web browser. It sends a URL across using HTTP protocol, and that is then dispatched by xinetd to the HTTPD program. It retrieves a web page from your hard drive and then sends it back out to the browser that requested it. HTML, which is what is in the file that's being sent back to the browser, is the hypertext markup language, and it is a tag-based language. Things are labeled with text tags, and it's kind of free format other than that. The tags have special meaning. There's like a tag for head, which is the content that goes at the top of the page. There's a tag for a division, which can be a section of the page. And then there's a tag for HTTP reference. So I can have something on the page which you can click on, which takes you to another web location, and that is stored in the tag along with the image name that's being displayed for that link. In this case, I just took a little bit of the code that generates the NOAA homepage. So you can see that the browser interprets this markup language, and it retrieves all the images and the text necessary to paint that screen for you, and then it will go and retrieve any links that you click on from there. That's pretty basic stuff. So where do I get Apache if I want to run a web server? Well, for Fedora, Red Hat, SUSE, it comes bundled as an RPM in the installation package. You just install it at install time most of the time. For Windows, you can download it as an MSI file from the apache.org website. You can also compile it from source. Like I said, if you have some special CPU that you want to run it on, you've got a C compiler, you can download the Apache code and compile it yourself. The Apache Foundation at apache.org also does a couple of dozen enhancements for web servers that add functionality. There's something called Tomcat. Tomcat lets you run Java code in order to generate the HTML that you send back to the user. So you can have scripts written in Java that run on the server that dynamically generate the web pages that are sent to the user, and I'll show you an example of that a little later on. There's just some examples. There's Camel for binding web services with something called Beans, which is a series of little subroutines that run special functions. There's Cactus, which is a test environment for Java applets, and so on and so on and so on. There's a lot of things available, and the Apache website is definitely worth visiting. So if I want to set Apache up as a server under Linux, I can do that just by installing it when I install the Linux on my system, or I can add it later using RPM or Yum. It's a fairly simple installation. And then if I want my server to be able to be found by other organizations, I have to give it a host name and make sure that that's listed in a DNS entry somewhere. That's pretty basic stuff. We covered that in the networking course. If you're using IP tables, and you really should for security purposes, that's the internal firewall on your Linux box, you can add to the input chain a rule that accepts from source addresses on the TCP and UDP protocol coming to port 80. You send those packets to the accept queue. We talked about IP tables again in the security course. The other way of doing this, of course, is just to go into the firewall GUI, which is available in your system configuration menu, and just open those ports. But you need port 80 normally for regular web traffic and port 443 for encrypted traffic. You can reassign HTTPD to listen to other ports. If you don't want your web server to be visible to the public, one way of kind of tripping people up is to move it to listen to another port, sometimes port 8080, or just pick a port number. There's 64,000 of them to play with. If you go into your config file and move the web server to another port, the people accessing it are going to have to type that port number in explicitly at the end of the URL. Put a colon and then the port number in order to reach it. You would configure HTTPD using its config file. There's also a GUI for setting up the basic parameters. Then you create some HTML content, we'll talk about that, and then start the service on your machine. You can use check config to start services. So check config --level 345 HTTPD on means if you're at run level 3, 4, or 5, HTTPD will be started. We talked about this in the class on bootstrapping. And then you can also start the daemon one time by using the script in etcrc.d init.d HTTPD start. So you can either set it up to start automatically when you boot your machine, or you can start it just once using the command line. So the config file for HTTPD allows you to set up a lot of different parameters that govern the behavior of your web server. There's a tutorial on this at that link, which doesn't turn out all that well in that font. Link fonts for some reason don't show up well on the projector. But this allows you to do things like set up your virtual root directory. This is where the web server is going to go to retrieve the files that it's sending back to browsers that are browsing your system. You can also set up virtual hosts. You can have one web server run more than one website by putting several virtual host names into this config file. Then your web server, as long as you put those entries into a DNS someplace so that those URLs resolve to your server's IP address, your server will then look at the URL coming in from the browser and it will find the virtual host that matches that URL, and it'll supply the content for that site. So you can have multiple websites on a single web server. So here are some of the parameters that we can put into the config file. One of them is listen. That's the port I'm going to listen to. And as I mentioned before, normally a web server is on port 80 for unencrypted content and port 443 for encrypted content. If you want to hide your web server, if you want it to be only for internal use or only for the use of certain people, one way of making your web server less obvious to people who are just poking around is to move that port to a different port, which people will then have to type explicitly into the URL to reach you. The server admin value is who do you send email to complain about this server. By default, it's set to root at localhost, so when somebody clicks on the web admin link in one of your web pages, it would send email to that address. And then the server name, which doesn't have to be the same as your host name. As I said before, you can have one or more virtual servers on this web server. There has to be a DNS entry somewhere that links that host name to the IP address of this machine. But as long as typing in that host name gets you to this IP address, you can set HTTPD up so that it looks at the URL and then matches it to one of several host names. The document root is the directory that contains most of the HTML files that are served in response to requests. The error log entry is where your error logs will go. Normally it's var log httpd error log. You can turn on something called hostname lookups. Now this is an interesting feature. You can have your server take the IP address of the remote host that's contacting it, or the PC, and look up its IP address so that you can have a record of who has visited your site. It's not very efficient to have this done by HTTPD. It uses up a lot of resources, so if you have a heavily trafficked site, this is probably not a good idea. There are utilities, which we'll look at a little later on, like Webalizer, which will capture the host names of the people visiting you and build charts and graphs that let you look at who's using your system. Okay, so let's say that we have installed Apache, we've set up its configuration file, we open the ports through our internal firewall, open the ports through the network that's coming to us, through the corporate firewall. Our server is all set up. The first thing people are going to see when they come to your server is the sample page that comes with Apache that says this is Apache that was written by the Apache Foundation. So you probably want to replace that with your own content. And there's several types of content that you can put in your web server. The easiest is just static HTML. Some of you have probably already done this, but you can write static HTML fairly easily without having to know the hypertext markup language yourself. Microsoft Word, OpenOffice, a lot of different packages will let you create a document and embed pictures into it and then export it into HTML format so that you can then display it as a web page. Once you generate an HTML file, you just move it to the directory var www.html, and it will then get served up to the user. The default web page, if somebody types in just your host name, www.noaa.gov, the default web page that gets served up to them is index.html from your document root directory. There are a number of tools available for free that let you develop better looking web pages. There's Composer, which comes free with Linux. That's Composer with a K. And it allows you to switch back and forth between viewing the HTML source code and viewing what it will look like when rendered in a browser. This is a commercial package called Trellian, which is available in an open source version. and it also has a number of tools like a drawing package, and it lets you do a WYSIWYG edit of your HTML page. What you see is what you get. So you can drag and drop pictures, and you can position text. But again, these are mostly for static content, which is good enough for a lot of uses. So, if you want dynamic data, if you want data that isn't the same every time someone visits the page, one way to do that is with RSS. RSS stands for Really Simple Syndication. And this is a protocol, it's an application of XML actually, and it provides a way of syndicating content and then aggregating it into a website so that you can essentially feed news feeds from news sources and embed them in your web pages. And NOAA has some sources, like the weather service has weather information that's available as an RSS feed. You would embed code that looks something like this in your web page, and then when someone retrieves that web page, their browser will go to the source cited in that code and downlink whatever the latest news is. And so that will appear in the web page, and it will be dynamic. It will be updated each time they visit the page. There are tutorials on RSS at rssgov.com and w3schools.com there. So if you're interested in RSS, there's tutorials that you can read that explain it a little more detailed. Now, if you want to access a database, there's a lot of different data that you can store and use in a website. It could be customer data, it could be satellite images with metadata stored in a database. What you can do is you can run a program on your server in response to a user's request. And this can be either a script or a compiled program. You can put compiled programs in the CGI bin directory, or you can write scripts. There's even, under Tomcat, a way to run Java scripts in a Java environment, and there's a set of class libraries that you can use then to access things like databases. But you write this program, which is then called up when the person sends a URL to your machine. Their requesting URL is passed to that program as standard in, and then your program would perform whatever functions it's going to perform, just like any other program on your machine would access a database or look up records. That program is then responsible for formatting its output in HTML format, and then it sends that output out to standard out, just like you were writing it to a printer or a screen. And then that gets sent by HTTPD back to the user as the HTML that they view as a web page. So this way you can have dynamic functions embedded in a web page that look up data on your host. This is just a couple of examples. If you had a compiled program that was going to generate a web page, then the browser would enter data into either a URL string or into an HTML form, and then that data gets sent to the program that's in the CGI bin directory. That program would do a database lookup or whatever calculations it's going to do, and then it formats its output as HTML, sends it back to the browser. If you're using something like Tomcat, then the input goes to the Tomcat program, and it would invoke a server-side Java routine. Then that routine would generate HTML out to the user. The user would fill out that form, send the input back to Tomcat. The Java program would act on that, and then the Java program would format HTML to send back to the user. We have an example at the end of these notes of an application that I used to be responsible for. It ran at the Department of Commerce and then migrated over to the U.S. International Trade Commission, but it was a directory.gov application. It had 18 federal agencies, and it had all of their email addresses, phone numbers, mailing addresses for their employees, and it used Tomcat and Java to allow users to come into a web form, fill out query data, receive a set of hits to that query data, and then select the user they wanted to look at and get their email and physical address, things like that. You can also send a script to the web browser. So you can implement functionality in two ways. You can either run a program or a script on your server and have it generate the HTML that goes back to the browser for the user to view, or you can embed a script in that HTML and have it run on the browser. Most browsers today support Java and a couple of other facilities, and they will accept scripts which then run in what they call a sandbox environment. They can't access your whole machine, but there's a limited number of functions they can perform locally. Those scripts can also do remote procedure calls out over the web to other hosts to gather data to be used to generate the display. There are some tutorials there on generating scripts for sending to the browser. It's a fairly complex topic. If you don't want to learn Java and you'd still like to have interactive content on your website that runs in a script in the browser, Dreamweaver, which is a COTS product, allows you to automatically generate JavaScripts for the user without having to know Java yourself. So here's a very simple example of a JavaScript. There isn't a whole lot to it, but again, it's an HTML program with a script embedded in it, and it prints out a little control box that lets you enter your name. Then when it gets the name back, it prints out a little control box that asks you to enter your IQ, and then no matter what you tell it, it tells you you're lying. This is not meant to be a real application, but it gives you an example of the kind of interaction that you can have with a user within a web page without leaving that browser. So you can interact with the user and collect data, which you can either return back to the server or use for actions during the interaction with the web page. There is a technology called web cookies, which generates a lot of interest and a lot of debate. Cookies allow you to stash data on a user's browser and retrieve it later. Some sites, for a while, and probably still, used cookies to identify things like customers coming back to a website. So if you were going to Amazon.com or JCPenney.com, they might stash a cookie on your machine that contained information about you as a user, so that when you come back to their website, they recognize you and they send you personalized content. You know, welcome back, Mr. Smith. Did you enjoy your last visit? The trouble is, cookies aren't secure, and people have hacked cookies. I had a friend who realized, I think it was at JCPenney, that they were storing his user number in open text in a cookie. So he started modifying that user number to see who JCPenney would think he was, and found out, yes, he could in fact get into other users' accounts just by modifying that user number in the cookie. For this reason, a lot of government sites don't allow the use of cookies because they're easy to hack and they're insecure. And people like me delete all the cookies from their system every session anyway, so it doesn't do any good to put one on my computer. However, if you want to learn about cookies, there's a couple of tutorials there on how to use them. Of course, it was not long before people building websites got tired of just showing people static pictures and text about their organization. People started to want to do more with websites, use them for collaboration in developing documents, or use them for blogs or wikis. A lot of web functionality is available pre-packaged, so you don't have to write it, which is a lot of fun because you can make a very productive website very quickly without a lot of effort. There are commercial packages available. Most exciting for me is that an awful lot of this stuff is free. Twiki is a wiki, which is, most of you have probably used Wikipedia. It's a community documentation site where everyone can contribute to the knowledge base on there, and it's kind of self-policed. Twiki is an open source wiki tool that you can install, and then you can have people collaboratively build a knowledge base on that website. Drupal is a document repository. It's a little different in that the content isn't all right there on the web page. You upload documents, and people can download them and edit them and upload them again. And it contains flow control so that documents get approved before they're published and those sorts of things. Drupal is actually used by the White House and the OMB. If you go to the White House website, it's actually running Drupal. There's a package called Webalizer. Webalizer is a web analyzer, and what it does is it captures the IP addresses and, if you tell it to, the host names of everyone who's visiting your site, and it will produce bar charts and graphs and things showing breakdown by day or by hour of who's using your site. It will also attempt to map people to geographic regions, excuse me, things of that sort. It's a very useful package, and it's free. Most of these things are available through a site called sourceforge.net. So if you go around, if you want a package to do something on a website and you don't want to write it yourself, chances are if you go poking around someplace like sourceforge.net, it's probably already been written. You can just download it, customize it a little bit, and then run it. Now this is the homepage from twiki.org. So you can go to twiki.org, you can download their free open source wiki package, and they have instructions on how to set it up and make your own wiki. This is the homepage from Drupal. Again, Drupal is a kind of a web portal and collaboration tool. Some people refer to it as a content management system. We'll talk about that in a second. But it also is available for free. You just customize it a little bit and you've got this wonderful website. And then Webalizer. Webalizer, again, will capture the web traffic coming to your site and allow you to put together charts and graphs of system utilization. These are wonderful things to show to managers. Managers love charts and graphs. So if you've got a manager that's after you to build a dashboard, throw up a couple of these Webalizer charts. They'll just be agog. They love that stuff. Sorry. Okay. All right, content management systems. If I have multiple people contributing to a website, if I'm the only one running my website, if it's all me and I write it all and I have control over it, that's fine. But if I have a more complex website and I have many people contributing to it, and especially if the content that's being posted to that website needs to be approved before it's posted to the production site, then I probably want to use a content management system. A content management system lets you download content, work on it, load it back into a library, and then pass it through a chain of command for approvals, and then once it's approved, it automatically gets published to your production site. The content management system doesn't have to run on the same server that your website is running on. If you set up your HTTPD correctly, then the content can be dynamically uploaded into your website from another server. There's several different CMS packages available. There's both free CMS packages and there's commercial CMS packages. Sometimes a CMS is kind of bundled with a web portal in addition. So something like SharePoint. You've probably all seen SharePoint. SharePoint, which is a Microsoft proprietary product, has content management features and then also has web portal features. It kind of runs the website as well as running the content management on the back end. Some of these packages are just content management systems. Some of them have the web portal features bundled in. Drupal, which we looked at before, is kind of both a CMS and a web portal. There's a package called Joomla, which is a very popular open source CMS program. Alfresco is available as a free open source package, but you can also pay for support if your management wants a supported commercial package. And Oracle, IBM, a number of other vendors have proprietary packages that do this. Here's the home page from Joomla, and there's tutorials on there that show you how to set up their CMS and how to use it to control and publish content. Here's the web page from Alfresco, and again, Alfresco is both free, open source, and is available as a commercial product if you want the support to go with it. And now we're going to transition into talking about Openldap. Openldap is a database which you can run on your server, and it's one of the applications that you can integrate into a website, which I had the responsibility for doing when I was at the USITC, and I'll show you the source code that did that. LDAP is a protocol, the Lightweight Directory Access Protocol. It was defined under a series of RFCs by the Internet Standards Committee. Openldap is one implementation of LDAP. Now, LDAP has also been implemented in commercial versions. For instance, Sun has a version of LDAP, which is the directory we in NOAA use with our email system. When you log into email or to sites that use your email credentials, you're authenticating against a Sun commercial LDAP implementation. But there's a very workable version of LDAP available as Openldap, and Openldap is available for free and can be run under Linux, Solaris, a number of different operating systems. LDAP, again, is a service that binds to a port on XINetD. By default, it's port 389, and you would use the LDAP protocol from a client to query over port 389. slapd would service that query. slapd is the program that actually implements the protocol and tends a relational database that contains the information. We'll talk about that a little more. Openldap comes with most of the Linux distros for free, so the easiest way to get it is just to install it when you install your Linux. You can also get it afterwards as an RPM file or as a .deb file for Debian, or you can compile it from source. OpenLDAP is very flexible. What it has is a series of schemas. These are just database record formats. But there's a series of database record files called schemas that you can link into LDAP when you start it. And it makes a lot of information available in a database, which you can access using either open query strings or from a program, or you can make that data available from a website. I'll show you how to do that. The Openldap program comes with a relatively limited relational database called GDBM. You can also set up Openldap to work with other data sources. You can map it to your Etsy password file if you're just using it for authentication purposes. If all you want to do is look up usernames and passwords in order to log people onto systems, you can set up a server that uses the Etsy password file as its data source for servicing LDAP queries. That would be very limited functionality. You can also use a MySQL database, and then you can add additional schemas. You can put pretty much any information that you want to into the database if you create a schema file to define those record fields. Then you link it in, and then when you run it, you can put data into that database and then retrieve it later using LDAP queries. The existing schema files are fairly extensive. They contain a lot of data, mailing addresses, email addresses, phone numbers, names, titles, organizations. There's a lot of room to put data about people into that directory. LDAP was what a lot of people think Microsoft was copying when they came up with Active Directory. So you'll see a lot of commonality between LDAP and Active Directory. Although, again, Microsoft has embraced and extended that to include new functionality. The most typical use for LDAP is for email directories. If you have your Outlook or your Thunderbird email client set up to look up names in the LDAP server, then as you type in an email address, you will go and look that up in the LDAP server, and it will auto-complete, and then it will validate those addresses. You can also, there's a protocol that allows you to look up phone numbers from a cell phone. So you can link a cell phone to an LDAP database and then use that to look up phone numbers for a group of people. You can also use LDAP for authentication, as we do with our email system. So other than just looking up information, you can store encrypted passwords in there, and as happens when we log into our email system, you authenticate the user using the username and encrypted password that's stored in that database. That functionality can also be integrated into other applications. If you need to authenticate users to an application, you don't have to set up an Active Directory to do that. NOAA has a perfectly usable LDAP directory, which is actually our authoritative source, for user credentials. And so you can just authenticate people against that LDAP directory. So if I'm setting up LDAP, I have to make sure the package is installed. I can either do that when I install Linux, or I can install the RPM file directly. You may also need to install, for security purposes, Cyrus Sassel and the GC libraries. Once you've got the package installed, you need to open up the ports through your firewall, and again, you can either do that by putting new rules into IP tables, or you can use the graphical user interface. Then you would configure your slapd.conf file, which is the configuration file that governs how the OpenLDAP protocol behaves. Then you need to build an initial database and then start the service on your machine. Now the config file, one of the important things contained in the config file for slapd is the schemas that you're going to use. You need to include the schemas, and the schemas are open text files, so you can look in the schemas and see what's in them. But you need to include schemas for all the records you're going to want to store about a person in order for that information to be available so that you can retrieve it when you do queries. The records that you put into that database work like a Christmas tree. You have to put, if you've ever assembled an artificial Christmas tree, you have to put the trunk up first, then you have to put the branches on, then you can hang ornaments on the branches. This database works something like that. You have to have a root organization, then you have to set up organizational units under that, and then you can hang people on those organizational units. And then you have data elements that refer to those people. Here's a couple of examples of a tree structure. I could have a domain of com, and then a subdomain of my domain, and then an organization of my company, and then organizational units for accounting and security and maybe HR. And then once I get down to the organizational units, I can hang people off of those. And then those people have data fields associated with them. Or in the government case, I could set up the country equals US. Then within that, the organization is the US government. Then I can have an organizational unit for, in this case, the USITC I used to work for, or the DOJ, or NOAA. And then under that, I can have any number of layers of subordinate organizational units, and then I can hang people off of those organizational units. Okay, so back to slapd.conf. There's a little bit of overhead in the configuration file. You set up basically the root of your database there, and then you include the indices that you want to have. There's something called an object class for a person called an inet.org person, and then you can select fields from that you want to be represented. So this is where you set up, you include your schemas, and then you set up the record types that you actually want to index about that person. By declaring a field as an index, it means you can search on it. If you don't declare it as an index, it's available as information when you retrieve information about that person, but you can't search on that particular field. So here you name the fields out of that object class that you want to be able to search on in this database, and then when you start the program, the database will be built so that those are used as indices. You can have subordinate LDAP servers, and you can replicate to a subordinate server. So this is information that you would embed in slapd.conf that shows how to set up a subordinate server that would link to the master server and then change information as records change. NOAA has a tree of LDAP servers. We have LDAP East and LDAP West, and they are replicas of the master LDAP directory, but what it lets you do is it lets you move the workload of performing these lookups out to multiple servers to kind of load balance and provide some redundancy. Now there's a related config file called lapd.conf, and this sets up the client software on your box. There's some client programs like slapadd and LDAP modify that interact with the LDAP database, and when you run them, they'll look in this config file to see where to go for the LDAP information they're going to interact with. If you have LDAP running on your box, you would want to point this file to your own box. If your LDAP is running somewhere else, but you want to be able to send records to it from your box, you would set that configuration file up to point to the root LDAP server. Okay, so let's suppose that I've installed OpenLDAP on my box. I've set up the slapd.conf file to include the indices that I want in my database and who the root user is and the root of the database. I need to provide information now to fill that database. Right now I have an empty balloon. I need to fill it with air. Information is put into the LDAP database and is modified in the LDAP database using a format called LDIF, the LDAP information format, LDAP interchange format. LDIF has a very simple but obnoxious syntax, and the ingest routines for OpenLDAP are unfortunately very unforgiving. So when you're formatting records to be put into the file, you have to have exactly the right number of spaces. You have to be very careful not to put alphas in numeric fields, that sort of thing. But here's an example of the LDIF file. These are the first few records from the LDIF file that built the root for directory.gov. The DN stands for distinguished name, and so I'm building a distinguished name for the U.S. government under the country of U.S., and then under that I'm adding an object, International Trade Commission, and it's the top of an organization. Then within the International Trade Commission, I'm building an organizational unit. Then I'm adding the Department of Energy, and then within the Department of Energy I'm adding their headquarters. So I'm building the root of the tree and then putting the branches on. Then I can hang the ornaments. Now here's another example. In this case, I have an organization called Stooges, which is the Three Stooges, and then I have a common name of Stooge admin within that organization, and then I set up member groups as organizational units within Stooges. So I can be a stooge and I can be a member of member group A or member group B. So here I have the root and then I have the branches. Now I can hang people onto those organizational units. Now when I go to add records to that database, I can do it with database either running or not running. If I don't want to interrupt the service, then I can run ldapadd, and I use the -f flag to identify the file that has those LDIF records in it. And then I would give it the distinguished name of the root user, and then the password. Now this is a bad way to do it. Right here I'm giving it the password in the command line. -w is the password. You can also do that interactively and have it prompt you for the password, which is probably the better thing to do. I can also run the script etc rc.d init.d slapd off, and then with the service turned off I can run the slapadd program. The two programs do basically the same exact function. They read that LDIF file which has those formatted records in it, and they post them to the relational database. The difference is ldapadd goes faster because the service is off and the whole database is available to the ldapadd program. Slapadd runs with the service on, so you can keep the service running while you're adding records to the database, but it's slower. The -c option is important because it will continue in the case of a syntax error, and again this program is very unforgiving of syntax errors. Be very careful about formatting the records, and there's information on that in the tutorials on LDAP. So again, each LDAP record is typically used to store information on people. People are hung as ornaments off of an organizational unit. The record for a person begins with a distinguished name record, which would have their common name, and then the organizational unit they're a member of, and then the organization or the country code. So you identify the fully distinguished person by their name, and then the whole chain of organizational units that they belong to all the way up to the root. That way there's no ambiguity, you know exactly who you're talking about. There are some data elements that are mandatory. You have to have object class organizational person, object class top. You need a surname or last name, and you need a common name in order for the database to be able to recognize the records. Here are some of the data elements that you can put into an LDIF record and store in your database. These are in the schema, so you can use the database to keep track of any of these data elements. Their car license number, their department number, employee type, their given name, their home phone, home postal address, and so on and so forth. Now, some of this stuff is what we would call privacy information. And as federal employees, we're not allowed to disclose privacy information. So be careful what you put. Even though the database can store it, it doesn't mean it's a good idea to put it there. Be very careful about disclosing private information about individuals you put into one of these databases. Here's an additional page of data elements. These are also available. And here's an example. That was my record up there. Common name John Unikas, organizational unit director's office, organizational unit information services, organizational unit operations, organizational unit international trade commission, organization U.S. government, country U.S. So if you read that chain backwards, you go from the root all the way down to my name. But that string uniquely identifies me within the database. And then it had my email address, my given name, my last name, my telephone number, my title, and so forth. So those are the records that were used to store information for the people that were stored in directory.gov. Again, slapd is just like HTTPD or any of the services that run under Linux. You can use check config and the levels you want it to run at and turn it on at those run levels, or you can turn it start, stop, or restart it using the script in etcinit.drc.d. Actually, I think I've got that reversed. I think it's rc.d.init.d. Sorry. When you want to access the data, let's say you've gone through all the work of building this database, and you say, okay, how do I get to it? There's a number of different ways of accessing the data once you've stored it. A number of authentication services will plug into LDAP. You just tell them where the server is. For instance, your Outlook or your Thunderbird client. You can actually go into the configuration routine, and there's a directory entry in the configuration. You just type in, for instance, out here we would use ldapeast.nems.noaa.gov, and then you tell it the port number and whether to encrypt it. And then that program will use our LDAP database to look up users. Active Directory has an extension that will allow you to just absorb an existing LDAP directory and look up things through Active Directory. You can also type in a string. LDAP is a protocol recognized by a lot of browsers. So you can use the LDAP protocol and then the IP address or URL and then the fields that identify the person that you're looking up, and your browser will display the information about that person on your screen. There's an LDAP search command if you're running on a Linux box. you can run the LDAP search command, tell it what host to go to perform the lookup, and then the name of the person, the identification string, and it will bring back one or more entries that match that. You can use wildcards in the search so that you can bring back one or more entries. There are also interactive web tools that allow you to both maintain and look up information in an LDAP directory. This is the directory.gov that I was running at one point. This is a web page that's generated by a Java program which is included in an appendix in these slides. The server was running Apache and then Tomcat on top of Apache, and then the server was also running the Openldap program. And so when a user came to the website, an Apache program running under Tomcat would generate the HTML for this web page and send it out to the user. The user would fill in name and organization information to look up a person. That would then get sent back to the Java program on the server. It would do a lookup in the LDAP database, and then it would come back with a list of people that met those criteria. You could then select one of those people and see their name, their address, their phone number, that sort of information. In order to change records, there's an LDAP modify program, and you use, again, LDIF format records to modify stuff that's in the database. You would give the distinguished name of the member that you wanted to modify. Then you can either delete their record using a change type delete, or you can modify their record using a change type modify. If you modify it, you would tell it what part of the record you're replacing and then the replacement value. You can batch up all those changes in a file and run that file through LDAP modify in one big batch, so you could do it, say, on a weekly or monthly basis. Okay, there's also a GUI, several GUIs. There's a program called Luma, and it allows you to navigate an LDAP directory and access and modify the records interactively over the web. There's a program called webdap and another one called webmin. All of these are open source and free. I've got the URLs where you can download them there, and then examples of what their screens look like. But if you want to use an LDAP database and you don't want to learn LDIF and worry about distinguished names and that sort of thing, you can just cheat and use the GUI. That was a joke. And there's a series, that font is really hard to read, I'm going to have to fix this for the next class. There's a series of tutorials and articles there on the various things that you can use LDAP for. So if you're actually interested and want to do some further reading, these are all valuable sources to go to. And I am not going to read this to you, but here are several pages of Java code. This is what ran directory.gov. So if you ever wanted to set up a website that provided a database that gave contact information for people in an organization, you can put Apache, Tomcat, and Openldap on a server, and you can put these JavaScripts into your Tomcat server, modify them a bit so that the heading and things are for your organization instead of directory.gov. Poof, you've got an instant website. Hopefully I didn't run over too badly. No, not too bad. Okay, that's pretty much it for this session. This is the last class in this series. People see, I sent out a little informal poll to see how people liked the class, and the responses were overwhelmingly favorable. Some people asked that if we run this class again, we do it in a setting where we can actually have labs. I think that's an excellent idea. I didn't know how many people were going to show up, and that's why I held it here in the auditorium. But I do plan to rerun this class, and next time I'll do it in a venue where we can actually sit down with laptops and play with some of this stuff interactively, which I think would help cement it in people's minds. Any questions before we go? Yeah.
Can you do a more advanced class?
Oh yeah, yeah. We can drill down into some of this stuff. Yeah, I had several people ask for more detailed classes. It's just they all ask for different topics. I would want to know that more than one person was going to benefit before I went through all the trouble of developing the material. But yeah, I think there are some topics a lot of people would like to drill down into. So yeah, we can definitely go into more detail. I'd like for people to come out of the next series of classes actually able to do things like go in and set up a website, at least a rudimentary one, so that they, instead of feeling like they just had a drink from a fire hose, they actually feel confident that they can apply the material in their workplace. Anything else? Yeah.
This gave you design website.
Can you speak a little louder?
If you want to design a website by yourself, basically you need the Java.
Well, you don't have to in order to generate web content. Some of those tools that I showed you, for instance, Composer. If you have Linux, there's Composer with a K, and Composer will let you drag and drop pictures and type in text, and you don't have to know HTML to develop a website using that tool. It's what they call WYSIWYG. What you see is what you get. So you just type the text, grab pictures, drag them in there and drop them, and it produces the HTML, which you can then load into the directory var www.html, and it'll get served up as a web page by your server. If you want interactive content that does more than just statically present pictures and links, then you'd have, if you don't want to learn the Java, you'd have to get a tool like Dreamweaver. Most of the web tools that produce scripted content are commercial tools that cost money, but it's not that much money. But you don't have to learn the underlying HTML or Java in order to develop the web pages. There are tools that hide that from you, and you just point and click and drag and drop, and poof, you've got a web page. Any other questions? Okay, well, thank you very much for coming, and if and when we hold another series of sessions, I'll send notices out for anyone who's interested. Thank you all. Were you guys able to follow that?
Oh yeah.
I know it was a lot of material in a short time.
Yeah, I just wrote down the cheat sheet.
I have a quick question, sir.
Yeah.
Is there any, is it possible that, you may come to our school and, teach a couple of students how to use Linux?
I suppose so.
Yeah, I mean, I don't know how it's the schedule like, maybe we can set up a date.
Yeah, it's I don't have a lot of free time because I have two little kids at home.
Right.
But it might be possible for me to come and do like a lunchtime class during the day.
Oh, alright, yeah, we can do that. Yeah, I don't know, maybe we can talk about it later.